I'm glad to be here to present my keynote talk. Uh, I'm really thankful to Dr. Kulkarni for inviting me here, and it's always pleasure to interact with different stakeholders. What I'm going to share here is that whatever we learn through these kind of meetings and interactions, and through a lot of partnerships with people like Dr. Sarvi, who have been supporting our research group a lot. He has been giving a lot of insights. I see in Nandu Sekar sir, when I was student in IIT Bombay, he used to come. So I learned from all these people. So big people are sitting there, so it's a pressure on me to say what new is there. So really great. I just put up some things in the context. Two things. The inaugural speeches said that today's problem cannot be solved with the same thinking what those have created. So what is that new thinking? That is what I'm going to talk about. The new framework that is emerging to solve this problem is the circular economy. Now, those who may not have heard this term or what is this new circular economy? This is nothing new. Recycling, reusing has been happening a lot since last few, let's say, years. But those were not becoming viable. So now to make it viable, and unless economy doesn't work as with the environmental effort, no environmental effort will be sustained for long. It will be just an initiative by some NGO, by some people, but it will not be sustained unless economics comes together. So to keep things on play, to keep things rolling on its own, the circular economy as a framework is proposed, which because economy terms so all get attacked, right? Because if you just say environmental protection, though as soon as circular economy terms comes, corporates, governments, politicians, all stakeholders, okay, kuch to economy ke bare mein hai, I should listen, and that's how the circular economy has catched a lot of attention. So technically, environmentally, what Dr. Milind or what Dr. Saxena, these kind of people have been doing for last many years, nothing new technically may not be happening. How to put things in the perspectives, how to make it happen in ground, those things are here. So I run a lab called Srishti Lab in IIT Bombay, and whatever I'm going to present is mostly from two students, Dr. Nikita, who has received guidance also from Dr. Salvi, Dr. Nikita Kakwani and Dr. Shweta Lokhande. These two students have worked a lot, so their studies and their work has led to all of this framework development. So what is the status of sewerage in India? If you see, we are stuck in a linear model of water use, okay? Because earlier our primary aim was to supply water, first of all, for the businesses and cities, that water should be there. So historically we build dams, reservoirs, from lakes we lift water, we transmit, big lines are there, we distribute, use, and then the contaminated water, used water is treated, untreated or partially treated, mixed with our lakes, rivers and water bodies. And that is our linear model of development that has been followed. Now so the STPs are basically proposed to fix this problem, that we'll have a STP here and it will solve. But STP will not work on its own unless you put energy into it, unless you put manpower into it, unless you put efforts into it. And to put that efforts, you need a money. So unless that money is not sustained, nothing will be there. So STPs are there, but they may not be operational. So many STPs are defunct, and that's wherever you go, those are defunct because economics has not been worked out for those STPs. So we have to work out the economics. There are highly centralized systems which are idle, that I have seen sewage treatment plants. I will show some photographs where they are remain idle. These are just white elephants. They are there sitting there, doing nothing. So see, the infrastructure is funded by some third party, right? Some central government funds, development banks, they fund the infrastructure, and urban local bodies are meant to maintain them by generating a revenue, and there is no strong revenue stream for sewerage or sewage management, okay? So revenue is not protected, not segregated for sewage management. So there are issues that I will further explain about this. So point is that merely creating infrastructure is not sufficient, okay? That we may think that, okay, infrastructure may solve problem, it may not. It is just infrastructure is there, but whether it is sustenance, whether it is working or not, that is very important. So, and what is happening is we are always jumping on some very high-end solution, that we'll have underground drainage, then the problem will solve. But if you see, the large part of our cities are unorganized. Informal settlements are there. There are many communities who do not have access to water supply. So for that, we need to have something called portfolio approach. Portfolio is that we have to have a bouquet of options given to communities to solve sanitation problem. If you just focus on only underground drainage network, only one large scale STP, that will not work for our future. So we have to move from this centralized sewer to other options are also there, which are not discussed, not prioritized. So like on-site treatment, decentralized sewer treatment, on-site storage and transport. So many other things are coming. So the sanitation service provisioning is one challenge, part of the challenge. Network configurations, a lot of focus is given on sewage treatment, but how are we designing the sewer networks appropriately, and how this entire thing to do sustainably is a question that I'm going to deal with. So to have the sanitation for all needs a very different approach rather than a conventional sewer based and STP based approach. So there are many wastewater treatment technologies. As we can connect toilet to tap, that kind of technology is available. So it's not about technology, whether that technology is feasible for the context, whether municipality will maintain that technology, those issues needs to be discussed. So what are the challenges then, overall challenges? That we are more focused, all the discussions happen in sewage treatment. If you see the cost economics, and again I'm coming from, although I'm working in engineering department, but my work is most on management and policy. So if you see the cost economics, that sewage treatment costs 20 to 30%, but the network costs 70 to 80%. But all the discussions and debates happens upon which treatment technology. That is not the problem, please. That is not a problem. The problem is whether our sewer networks are laid properly. I have seen many cities, I will not name them, but where the sewer lines are laid opposite of the slope, gravity. Just a rush to lay down the sewer system. The zones and the planning is not done properly. So even if there is a sewage treatment plant, it is not functional. That is not receiving the sewage first of all. Functioning comes second. Our sewage treatment plants are not receiving sewage in the first hand. So this is in some of the sewage treatment plants. For example, Nanded, they had a sewage treatment plant in 2010 with the capacity of 87 MLDs. Even after these many years, the half of the sewage is not received. So infrastructure creation is happening, but utilization is not happening. We have the sewage treatment plants where the DPRs are done so fast that cow dung is reaching to our sewage treatment plants, or the whatever tabelas are there in the cities. So this is the situation, because as an environmental engineer, I learned from these big people. The first thing as an environmental engineer, we are taught that do the site characterization. How many people are doing site characterization today's time? People are just rushing and preparing a DPR, and that's not to blame to any consultant or anyone. It is a ecosystem that is asking to put a pressure on consultant. Next week you bring a DPR. That's not the way we should ask consultants to prepare a DPR. So site characterization, feasibility, no primary treatment, directly sewage secondary treatment. This is basically failing the first principles of environmental engineering. We have moved away from our own knowledge base. India as a traditional country, cultural heritage. So for sewage treatment, we had nature-based solutions. This is from Karad, okay, from Kolhapur. So we had nature-based solutions, which were now converted to mechanized systems. Okay, so those transformations have happened. So nature-based systems were there as a part of our culture. There are very nice handbooks written by some very great people from different colleges that time, how to maintain and how to do nature-based. Those lands are now taken over, and part of the land is given only for assuming that mechanized treatment system will work. It will work if somebody put attention to it. Then what happened in Bangalore and part of Mumbai also, that because these things are not working, people thought, okay, let us do something at building level. And now building level STP is another trouble, okay, because my view on building level STP is we should not put a burden on a housing society to put a building level STP for a very small capacity, because that is not their job. Because having a STP is like adopting a baby. You have to feed chemicals, you have to put check the pH and check the everything, every parameter, which how housing societies can maintain, even, and there are not good vendors available. So Bangalore crisis happened because municipal STPs were not working. And building level, 4,000 STPs they had at building level, 4,000. 80% are not working. So they thought they will do treatment, and the building thought municipality will do treatment, and nobody was doing treatment. And then the groundwater was only extracted, so we had a crisis like Bangalore. So we do a lot of such studies. This is BMC's. So BMC is the only corporation to do a preventive management, and that is because of Dr. Salvi. Preventive and we studied the preventive maintenance part. How many municipalities have that capacity to maintain underground drainage systems? Very rare. Okay, and then BMC has to go as a big brother or a sister and help other municipalities to train them, and they have a municipal capacity building research center. So concerns are there for small ULVs. Okay, there are many concerns emerging from small local bodies. BMC can manage because they have a capable people like Dr. Salvi, where many such people who are helping the municipality to maintain the infrastructure. This is the reality of small city. This is from Dhanu, okay, where we have worked with big cities like Mumbai also and small city like Dhanu also. Now see the DPR prepared here, and when the chief officer called me, he said the DPR cost seems very high. What is happening here? See, this is a Chikku farm. This is no habitation. This is small scale industries. So there will not a possibility of flow for next 10 to 20 years, but sewer lines are laid here, are proposed to be laid here, and that is because DPR cost will be increased. So if cities get this kind of, and there are 7 to 8 pumping stations that municipality, this DPR has, that all sewage will be pumped to one location and one STP will be planned. That was the DPR proposed. Now what will happen with this? How the municipalities, such a small municipality, maintain this sewage, such a complicated sewage treatment? So we have to change our practice. That excessive pumping proposed, unnecessary sewer lines proposed in areas with very less population, low velocities. I checked, 60 to 70% of the sewer had less than 0.6 meter per second velocity. That is technically not correct, but the sewer lines were proposed here. Okay, and such DPRs are getting sanctioned and approved. So these are the things we have to see, that where the things are going wrong. So several insights and motivation for our research are there. That lack of focus on operation maintenance, only infrastructure creation focus is there. Lack of adequate consideration of study area specificities. What works in Dhanu will not work in other city. Dhanu has a very nice topography for nature-based solutions. It is a pond-based town. Very nice ponds they have. So those ponds can be taken into the system, and very nature-based solutions can be used there. Lack of studies quantifying the natural treatment systems. Okay, there are nature-based solutions at different levels, different configuration can be done, and there is a decision support is not available. BMC has capacity to think and plan something, but small and medium cities do not have any capacity to do the things in right manner. Okay, so they are dependent on many. They are basically do not have any guidance. And one solution doesn't fit to all, and that is true for our country, very, very true, because you see, we have metro cities, we have million plus cities, we have tier 1 cities, we have small cities, we have coastal cities, we have arid regions. So if somebody is saying this is the solution, it is not possible. The solution has to be tailor-made. The solution has to be contextual as per the local condition. You can have the first principles and design what is required at the ground. So, and that's why diversity is our strength also, right? Because we have such a diverse, so knowledge base that is created in India is huge. So what is wrong in the current approach? And this is one classical paper that we wrote, that cities, let's say this is our system boundary where cities are mapped into this box. We have water reservoir, maybe dams, lakes, groundwater. So historically what we are doing is we are bringing the fresh water for housing, industries and agriculture. And agriculture is basically having, don't know, something is not visible here. But here is agriculture land patch, somehow it is missing, and it is really missing in on ground. But the agriculture patch, they receive nitrogen, phosphorus from again industries. Now why I am showing this? When you study the things from system perspective, from life cycle perspective, many things emerge. So you have to just expand the scope of analysis. What happens in cities affects other regions. So nitrogen, phosphorus is, for example, to fix nitrogen, huge amount of energy and hence carbon emissions will occur. That nitrogen, phosphorus is applied to this agricultural land. That agricultural land provides food for our houses, and detergents and chemicals, all that comes to our houses, and we assume that the sewers will take care and centralized treatment will happen, but actually it is failing many times, and then this entire contaminants are going into our local bodies, these water bodies. Okay, so we, and again we are putting energy. So see the smartness we have evolved into, that we are again putting energy to take out the nitrogen. So one level of energy intensive process is happening to fix the nitrogen to generate the fertilizers, and another time we are putting energy to take out the nitrogen, because environmental engineers are looking here, chemical engineers are looking here. These two engineers do not talk to each other. See, because nobody has looked at the system level. So system level is that we are fixing nitrogen, we are taking out the nitrogen, and all both are energy intensive processes. So something drastically different has to be done. How we can generate sludge and compost that can be put back into our original system, so that this cycle can be broken. How we can reduce the freshwater consumption and reduce the pollution, and create a new local water systems for recycling for different purposes. So we have to have a local loops of water, rather than putting everything back to the original sources, so that the fresh water can be preserved, and energy generation can also happen from sewage treatment. Those all concepts are there, we are not applying it in a appropriate manner. So and there is a decentralization that also can be done. So what we need to do is we have to transform this linear way of doing things into circular by applying reduce, reuse, recycle, reclaim, recover, restore, and many other R's. By innovating, we can apply for fixing this problem. Okay, so what are these R's? See, our water transform this between natural environment, water treatment plant, urban areas, wastewater treatment plant, industries, and agriculture. So water get exchanged between these entities, and they have their own physical boundaries. So we have to apply reduce at every level, reuse at every level, recycle, reclaim, restore, and recover. When we started doing our research, we found that there is no meaning to this term. People are using synonymously, which is a problem. So we defined these terms technically: what is reduced, what is reuse, recycle, reclaim. For example, recycle is use of treated wastewater within the same purpose or same loop. If buildings are recycling, if nearby buildings are recycling, it is recycling. If municipality is selling water to industries, or industries taking water from municipality, it is called reclaim. Okay, and recover is you recover the resources from the system, and restore is excess treated water. Many cities, many townships are having excess treated water. For example, 2-3 days back I was in Palava city. They have excess water, treated water, 10 mld. Now they are selling to industries. That is reclamation and restoration efforts, those are there. Now all that research is taken up by Central Pollution Control Board, and if you see their guidelines, they have taken the definitions that we have given from our research. That is our let's say contribution to the policy making. So the next part is, you will say, okay, in my city what I should do, which strategy I should start working, because as I said, solution for Mumbai and solution for Nagpur or solution for Hyderabad will vary a lot. Okay, so you have to have a priority framework for a given city. So where to start? Reduce is definitely, you have to do reduce everywhere, it is universal. Then whether to reuse, recycle, reclaim, that is the another research we concluded. Those who are interested can read the papers. I am not going to present a lot of technical details, I am just presenting the broad ideas, that only saying that I will work on circular economy will not work. Prioritization at local level has to happen. So, and then as said in the inaugural speeches, unless you do not work with many other stakeholders for system thinking, for value optimization, for innovation, collaboration, stewardship, and transparency. Transparency is very important. What municipalities is doing, what every stakeholder is doing, that all principles of business has to apply to this circular economy. So this combination has to happen, and then only things will move in some right direction. So the challenge for water circularity is that effluent produced, whether it is recyclable quality or not. In today's time, we are facing huge challenges. We have some trace persistent contaminants which are very difficult to remove. Our rainwater is found plastic, microplastics. Our rainwater are is also not become pristine. Okay, so that is because we have emerging contaminants, household chemicals, the amount of pharmaceuticals used in houses, amount of chemicals used in houses, those all are going into sewage treatment plants, which are not equipped to take care these very toxic compounds. So even if you do this, whether there is a market for recycled water, because somebody has to ready to receive that water, right? You may produce, but if community doesn't ready for receiving that, even for flushing water, I have seen housing societies who deny to use recycled water for flushing, and that mindset has to change. And Rotary Club and many other organizations have a role to play to convince societies to have little bit of let's say consideration for environment, to have flushing water for landscaping and all. So so in this direction, to improve the water circularity, we have also developed something called measuring water circularity. So we can measure water circularity for building level, for city level, for regional level. So and then prioritization of circular economy, and what are the pathways that I will share. So this measuring, this is one of the another successful study we completed, where how to measure water circularity. That is Nikita's work that is completed. Now, what are the pathways of achieving this circular economy that I will share? Few examples I'll share. Reduce is one of the neglected strategy, because whatever we are doing, first effort that whether we can avoid at all the consumption. So reduce and refuse. So if we apply these potential water fixtures and community behavior, many people do not know how to use washing machines. We have done surveys. People don't know how to use washing machines, because washing machine consumes a lot of water and chemicals. And if your washing machine is not used properly, fully loaded, and how much water to be used and chemicals to be used, a lot of water wastage happen. So in this direction, I did some experiment at my home. Okay, this is very one funny story I keep telling in my classes and all. My IIT gives water and BMC gives much cheaper to us, so we don't care, as we have a huge water consumption. So I measured water coming in my tap, which was coming 12 to 15 liter per minute. Okay, so typically if you open a tap, you will get is 12 to 15 liter per minute. Okay, that is a standard water tap. I was feeling bad that so much water I'm preaching and I'm not doing anything at my home. That should not happen, right? Some of you can question me, like, what you are doing at IIT and your home. Fully you can ask. So I thought, okay, let us do something drastic. So I bought some these aerators and I fixed it. Okay, right? I might have solved problem. The next day, maid said, I'm leaving. I don't work in this house, because maid cannot work with this kind of water flow. They are habituated to this water flow. They have to quickly wash the utensils and go to the next house. Please understand. Even you try to do this and you will get bored, because the water is not enough. We are habituated. So our habits are with this flow. So then wife said, you do the utensils or you remove this. Your choice, right? And that's the circular economy. It will come to your personal level. Okay. Then I thought, okay, kya karenge? I had to become more smarter. Okay. Then when nobody was at house, what I did, first I put it back, okay, for a couple of days. Then when nobody is at house, I bought a 6 liter per minute tap aerator. See the difference. Now they even don't know today that I have done this. A maid is not also complaining, because she thinks the same amount of water is good. It's just a perception. Okay. It is just playing a trick with the mind. So I saved 50% of water without telling anyone. Okay, because and now no quarrel, everything is happening. So that's the circular economy, that when you have to do some things in a very tricky manner, without telling people, without telling that same thing you are doing, but just thoda sa tweak kar diya. That is the, and if you imagine, if entire Mumbai start doing this, hundreds of MLD of water is saved. We don't need a new dam, we don't need a desalination plant. A lot of changes will happen and a lot of public money will be saved, and it will be in a sustainable path. So problem, we have to stop creating problem instead of solving the problem. So a lot of such studies we have done, and then we have developed the rating system. Like you have energy rating system, we have developed rating system for houses. And that with the foundations like Prakruti Foundation, we can do the house community rating systems. So BMC's average capita consumption is around 200 LPCD, and if you do even with work with 30% top consumers, 500 mld water can be saved. Top 30% consumers, if we decide to work, so lot of potential is there in reduce, which is not talked, not worked, not promoted. Okay, municipal commissioners, municipal team do not work on those aspects largely. So that is the reduction part. Let's say after doing that, you have still have used water. What to do with that? So there are various approaches of doing used water management. One is this I explained, and then you have to have household or building level, decentralized and centralized. What does that mean? And there are many technologies. I will not open this box. There are many technology providers in the market. They are ready. You give them the volume that you want to treat it, they will come. Largely mechanized, and now a lot of technology providers in nature-based solutions are coming up. That's good news. Okay, there are a lot of nature-based solution providers are coming. As I said, this largely created sewage treatment plant, centralized sewage treatment plant doesn't work. I have seen the sewer depth going 16 to 18 meter, very difficult to maintain. I have seen the STPs defunct like this because of a variety of reasons, as I said. I have seen both mechanized and nature-based solutions, and there is a confusion between people which technology to adopt. So there is a discussion is whether to do centralized, that everything you take out, or do decentralized or building level. So different scales of treatment can happen. Now question is what scale we should do the treatment, and that's what research I give to one of the students which is completed now. So what is the how we frame this problem is highly centralized STPs are not working, highly decentralized, that means building level STPs are also not working. And your parameters of assessment is sustainability and resilience. What are those? How we can quantify sustainability? Like we can talk about sustainability, but we have to measure the sustainability. So for measuring the sustainability, we have to use life cycle cost, which comes lower at some middle level. We have to apply social benefits. We have to quantify social benefits. We have to quantify potential for recycling water. We have to quantify resource recovery. We have to quantify ease of governance. Whatever we are giving as a solution, municipality should be able to govern. It should not require another third party to entirely maintain that infrastructure, and lower environmental impacts. And then so overall sustainability will be better at something doing at the mid level. So and the new expectation is the climate resilience, which I will not go into deeper, but that also works out better for smaller systems, not the mega systems. So ideal zone for achieving sustainability and resilience is somewhere in between. So we wrote this article, which is most downloaded article now in Water Policy Journal, which is need to adopt scale decentralized systems. Okay, why I'm saying this, that when I see cities like Dhanu, when the consultant prepare a DPR that only one STP of 10 mld will come, what I'm saying is you split it out, have 1 to 2 mld or 3 to 4 mld, at least 2-3 STPs, so that local recycling can happen. Similar logic for cities like Kolhapur or smaller cities, Nanded, where you can split up the STPs, Pune and Mumbai kind of metro cities, where you split up the STPs and have a local recycling stations instead of putting everything in a very far distance and again putting it, bringing it back. So if we really want to do recycling and reclamation, we have to split up the infrastructure, and decentralization is a path. So so our students have created this very nice video for those who are not from this sector or those who want to understand. Very good animations they have created. They went beyond publication, they went one step extra and created this video for dissemination of this knowledge. So what this research means, like so this on x-axis you have the capacity of let's say STP municipal capacity, and Pune, this is the ideal scale for Pune city, 64 mld, let's say 60 to 65 mld. What Pune city is doing is very large or very small STPs, not at the scale. Similarly for Mumbai, what we studied is Mumbai is doing mega STPs, or two small STPs, decentralized STPs are also there. But the ideal scale is this, so that recycling happens locally. Now you do not need another tunnel to take the sewage from here to another location, which is costly, not sustainable, not climate resilient. So what I'm saying is, if this is the city And if you are building a very long sewer to take, another hazard that comes is how to maintain this, right? There are many cases happens that workers die and all that. So there are safety concerns also to maintaining deeper sewers, and deeper sewer happens because you plan for centralized systems, then it creates a lot of problem. So what I am saying is that instead of doing planning, so you see that you have to take back the water to different recycling locations if you have only one STP, and if you plan the smaller zones, then you can have the localized recycling. That is the point I am trying to make. And then there are many concepts like you have to account for life cycle costs. Okay, that right now the decisions are made only based on capital cost. That municipality thinks what is the current capital cost, but if you see the amount of electricity that is required to maintain the infrastructure for next 30 years, nature based solutions work out much more better because they do not need electricity. So there is a choice that we have to make whether to go for a decentralized systems and what level of decentralization, whether to go for a mechanized systems or whether to go for a nature based solutions. So and both do not work in many contexts. So hence we come up with another concept called hybrid treatment systems, where we take a mechanized treatment system, best of the best mechanized treatment system, and then combine with a nature based system, because energy is more for mechanized system, whereas land is more for nature based solutions. So there is a trade off. If you see, this is the BOD level, outlet BOD level, and this operation maintenance cost. For high end treatment, mechanized treatment, you require 15 to 20 rupees per meter cube or even 30 rupees per meter cube, whereas nature based solutions are cheaper for operation. But the land cost meter square per MLD is very high for these green systems which are nature based. So that's why those are not promoted, because land cost is high. But what I'm trying to say is, if you shift from 30 BOD, you do the best part using mechanized treatment system, and policy treatment you shift to nature based solutions. So you integrate both of them and then you achieve the sustainability. We did a market analysis. If you buy a land from market at 2 crore rupees per acre, okay, Mumbai chhod do, but in many other cities it will work. Even if you buy land at 2 crore rupees per acre, in every context, nature based solutions, constructed wetlands or hybrid treatment systems are better than any other mechanized system if you do the life cycle cost for 30 years. So municipality has to see that whether they want to maintain the infrastructure for next 30 years. So in the economic evaluation, operation cost plays a major role, which is often forgotten in the decision making. So if you have to achieve the sustainability, we have to do a change in the thinking of how we do the economic analysis, how we procure the systems, how municipality take the decisions, and that's hand holding as an academic body from IIT Bombay, as a Rotary Club, as a Prakruti Foundation, as many stakeholders we have to do. So many such concepts are there, but I will not give more time to this. We do a lot of such scenario analysis, so we will be happy to support in many municipalities. There are many climate change benefits. If you go for nature based solutions, you can save money as well as carbon, and that carbon can be traded, and that can be also taken into account. So many opportunities which municipalities are not trained right now, that can happen, and we have shown how much reduction is possible if you use at a national level. So and we have to work for creation of recycling market. If you do not work, if you have only STP and recycle water, and if you do not have the agreement with the MIDC and agreement with the industrial clusters, recycling will not happen. Okay. So this is one of the example based on our research. One of the company in Himachal Pradesh adopted hybrid treatment system, where they did some part using mechanized system and they clubbed the constructed wetland and the stabilization pond, and the success of the project is market for recycled water is ensured. So many of this research is taken up by some companies where they are trying to do things differently by combining both the systems. So I will stop here, but many such solutions are available, and if any questions I will take rather than just telling. But some personal experience I shared, some municipal experiences I shared, some industrial experience I have shared, and a lot of this research is available in our websites, and you can refer, and I will be happy to collaborate on these topics. Thank you.